Hello, welcome to Lead Programmer. Today, we are going to look at the question longest palindromic subsequence. So, we are given a string and we have to find the length of the longest palindromic subsequence in the given string. So, first, let's see what's a subsequence. So, let's take the example of A, B, C, D, E, and let's consider two strings ACE and AED. Now, we can derive the string ACE from the given string, which is ABCDE, by removing a few characters. So we can remove B and D from the given string to obtain ACE. And ACE is said to be a subsequence of ABCDE. So essentially, by definition, a string that can be obtained from a given string by the removal of zero or more characters is a subsequence. But one important thing to note is order matters. So, therefore, AED is not a subsequence of ABCDE because although AED contains characters from ABCDE, but the order isn't maintained. So, as we can see, the order, uh, so in this string, E appears before D, but in the given string, E appears after D. So, since the order isn't maintained, it's not a subsequence. Okay, so with that out of the way, we have to find the longest palindromic subsequence. Now, what's a palindrome? So, consider A, B, C, B, A. If you read each character from the left to the right, and you read each character from the right to the left, it's going to be the same. So, from the left to the right, we see A, B, C, B, A. And if we go from right to the left, we see A, B, C, B, A. And it's exactly the same. So those strings are said to be palindromes. Um, okay, so let's consider the example given. So in the example we have B, 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 A, B. So in this, B, 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 B is a subsequence because it can be formed by removing A and the order is maintained. So it's a subsequence and it is the longest, and it is also a palindrome. So BBB is a palindrome because it reads the same from the left to the right, and it is also the longest palindrome because other possibilities are BB or BBB, but BBBB with four B's is the longest palindromic sequence, and hence the answer for this is 4. In the next example, we see CBBD, where one possible palindromic subsequence is BB and is the longest, so the answer is 2. So, when we look at subsequence questions, it mostly pertains to solving by dynamic programming, specifically 2D dynamic programming. So, you might have seen a question which is longest common subsequence, where we have two strings and we find the length of the longest common length of the longest common subsequence. If you haven't solved that, that's fine. Go through the idea of we'll go through the idea over here. So it's a 2D dynamic programming question. So essentially, we have a 2D grid to solve the problem. So let's get into that. Firstly, let's recall what we saw in the longest common subsequence question. So in that, we were given two strings, A, B, C, D, E, and ACE. The longest common subsequence would be ACE because ACE is a subsequence from these two strings, and it's the longest. So the answer would be 3. That's its length. So the way we solved that question was we had a 2D grid On one side we had A, B, C, D, E. On the other side we had A, C, E. And the idea over there was, so let's say we first begin over here. So we see we have A and A. So essentially being at this particular cell, being at this cell means we are trying to find the length of the longest common subsequence between this substring, between this string and this string. And each cell represents the length of the longest common substrings between this string and this string. So so at this cell we notice the two characters A and A. These two characters are the same, which means that in our longest common substring, we in our longest common subsequence we have one character which will be there in the longest subsequence, and we would have to look at the remaining subsequence, which is this and this. So therefore we look at the diagonal of that particular cell, and in this particular cell we it means that we are trying to find the subsequence of this particular string and this particular string. And over here we notice B and C are not the same, which means that the longest common subsequence at that position would essentially be either whatever is at this position, the longest common subsequence at this position, or at this position. So we just take the max of it. So being at this position means we are looking at the common subsequence, longest common subsequence of C, D, E and C, E. And being at this position means B, C, D, E and E. The reason we are doing it is like this is since these two strings are not equal, we want to find some other possibilities. So in one scenario we include this B over here and we exclude this C over here, and in the other case we exclude B over here and include C over here. So we try to find the longest common subsequence between B, C, D, E, B, C, D, E and E, or C, E and C, D, E. So the maximum of that is taken over here in this cell. For a longer explanation, I would highly recommend you to check out the longest common subsequence video that I have posted. But essentially, this is the main idea of this question. And another thing to note over here is we have two columns over here. Here there's nothing, it implies empty string. So let's say we are at this cell, it implies we are trying to find the common longest common subsequence between an empty string and A, B, C, D, E. So the longest common subsequence of an empty string and anything else is nothing, right? It's 0. So we have a 0 over here, and the same implies here, because the longest common subsequence of any string with an empty string is 0. The same comes over here, because being in this column over here implies longest common subsequence of an empty string with some other string. So we'll have all zeros over here as well. And then at the end we told that, okay, so instead of going brute force, instead of doing some recalculations, we start from the bottom right and go all the way bottom. We go all the way to the top, and that will give us a linear time of the big O of the length of string 1 into the length of string 2. So that was kind of a short explanation of that. For a deeper explanation, you can have a look at the longest common subsequence video. Okay, so now how does the longest common subsequence apply to this problem, which is the longest palindromic subsequence? So let's see what a palindrome is, right? So let's consider A, B, CBA. So we say that ABCBA is a palindrome because if we go from left to right, we read it as ABCBA, and if we go from right to left, we read it as ABCBA. You might notice that each of the characters over here are equal. So in a way, if we take a string and we reverse it, then it essentially translates to having two strings and finding the longest common subsequence in them. So let's take another example. Let's take the given example BBBAB. So if we read it from right to left, we have BBBAB. If we read it from sorry, this was left to right, and then from right to left, we get BABBB. So now if we translate this to a grid, we essentially get BBBAB over here, something like this, and we get BABBB over here, something like this, and then we can just draw these rows and columns like this, and yeah, that's it. So we look at this position, we see okay, B and B are the same, which means it has to be included in the subsequence. So we have 1 plus whatever we have over here. Over here we see, oh, A and B are not the same, so we'll take a maximum of what is here and what's here, because we either want to skip this character or we want to skip this character for this given cell, and hence we go to the right or to the bottom. So the same logic as the longest common subsequence. So let's look at the code. Again, this is pretty similar to the longest common subsequence code. So we have two strings. The first string is whatever is given, that's the string S, and the other string is the reverse of that string. Here we define a 2D matrix. So essentially this part over here is responsible for the array which looks something like this, which defines a row, and to replicate, and we do it for the string 1 plus 1 length, and then we want to replicate it the length of string 2 plus 1 times. So we have a for loop which does it. This is like a Python specific syntax. So we see that the number of rows are the length of string 2 plus 1, and the number of columns are length of string 1 plus 1. Here it's not necessary to have string 2 as a row or string 1 as a column. It can be interchanged and the solution would still remain the same. So here we have a for loop, we have a nested for loop. So inside that we have a specific I and j value. So we check if the characters at I and j are the same. So as we saw here, if the characters are the same, then for this particular cell the value would be 1 plus whatever value is at the diagonal of the cell. So we do the same thing here. So it's 1 plus the diagonal is dp at I plus 1 and j plus 1. Otherwise, if they're not the same, then as we saw over here, we find the maximum of the right and bottom cell. So we find the maximum of the right and bottom like so. At the end, we might have noticed over here we run a reverse for loop, which means we go from the bottom right to the top left just to avoid repeated calculations. So at the end, our final answer is going to be at this particular cell over here. The reason being this particular cell represents the longest common substring from this part of the string and this part of the string. So hence over here we return dp at 0, 0. Again, the time complexity of this is going to be the big O of n times n, where n is the length of the given string. and string 1 and string 2 have both have the same length because one of it is the reverse of the other. So it's big O of n square. And the space complexity is also the same because we have a 2D matrix which stores values. So it's big O of n square, which grows as the size of the input grows. I hope you found this helpful. Please like and subscribe the video if you found it helpful. Thank you.